So prime numbers are only divisible by itself in 1, meaning that it cannot have any other factors besides itself and 1. So an example of this would be 5, which if you have 5 little circle things, 3, 4, 5, you cannot divide it equally in any way. You can have 2 there and 3 there, but that can't work because there's not an equal amount on each side, so the only way would be to have 1 of 5, which you already have up here. But composite numbers are numbers that have other factors besides itself in 1. For example, like 6 would have 1, 2, 3, 4, 5, 6, and you can divide that into 1, 2, 3, 2 groups of 3, or 3 groups of 2. So it's not prime because it can be put into more groups than just itself. So yeah. Okay. So to find the first 100 prime numbers within the first 100 numbers, you must first have the first 4, which are all under 10, which are 2, 3, 5, and 7. And to find all of them within 100, you cross out the multiples of 2, 3, 5, and 7. So I cross out 1, 2, 3, 5, and 7, all the multiples of 2, all the multiples of 3, so 6. Okay, so after crossing out all of the factors of 2, 3, 5, and 7, we're left with 2, 3, 5, 7, and then 11, and 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 50. Okay, so after painstakingly writing them out, we're left with 25 prime numbers in between 1 and 100. And so the person who came up with this neat little trick for finding all of them is Eratosthenes, who was a Greek thinker, and he created this during his math studies.
This equation is one of 2 equations to be able to either find a prime number or a number that is not prime but has prime factors. An example of using this would be 2 times 3 times 5 in parentheses plus 1, and that would equal 31, which is a prime number. Using this equation is multiplying 2 times 3 times 5 times 7 times 11 times 13 and adding 1 to it and getting 30,031, which is not a prime number. 30,031 also has factors of 509 and 59, which are both prime numbers. And if you multiply them together, they also equal 30,031. The equation to find a prime number or a number that has prime factors is raising 2 to the power of a prime number and subtracting it by 1. An example of using this equation is raising 2 to the power of 3 and subtracting it by 1, and that equals 7, which is a prime number. And another example of using this is raising 2 to the power of 17 and subtracting it by 1. And that equals 131,071, which is also a prime number. A fun fact is the longest found prime number ever is raising 2 to the power of 74,207,281 and subtracting that by 1. And that number is much larger than a googol, which is a 1 followed by 100 zeros.